let's take a moment to examine these values of x, the amount we're increasing each dimension by, and A, the total area of Grant's display space, or at least the ones that we've seen so far. The original area, before we added anything to either dimension, was 150 square feet. When we added 1 foot in each direction, the area changed to 176 square feet. So in the transition from this point to this point, x went up by 1, and A went up by 26. Let's see what happens in the next transition. Once again, x went up by 1, but this time, A increased by 28 instead of 26. This is what we call nonlinear behavior. Remember that for a straight line, which you can write as y equals mx plus b, m, the slope, is going to be the same regardless of which points we pick. The change in x is always going to be the same. The change in x value is always going to have the same proportion to change in y value. The change between two x values and the change between two y values is always going to obey the same ratio. That is not what's happening here. This equation no longer applies. A change of 1 foot in dimension doesn't always increase the area by the same amount. This is a pretty interesting problem to have. Remembering that area is equal to length times width, can you come up with an equation that we can use to figure out what value of x will give us an area of 300 square feet? So think about how x will be involved in both the length and the width of this new area.